Assalamualaikum. I welcome all again in the lecture of pathology. I am Professor Shamsudjaman, Professor Pathology. Already I have given 4 lectures. My last lecture was on metaplasia, and I have finished a lecture regarding the cellular adaptation. Today I will deliver the lecture on cell injury. Now come to cell injury. What do you mean about cell injury? If a cell is exposed to certain stimulus or certain injurious agent, the cell tries to accommodate the injurious agent, that is, it is called cellular adaptation. If the cell cannot accommodate the injurious agent or the environment, the cell cannot adapt. If the adaptive capability of the cell is exceeded, then the cell undergo injury. Now come to what is the definition of cell injury. If the adaptive capability of a cell is exceeded to stimulus, the cell follows a sequence of events. This is loosely termed as cell injury. So again we recall, if the cell can adapt this cellular adaptation, if the cell cannot adapt the situation, it follows a sequence of events. This is loosely termed as cell injury. Now come to what are the types of cell injury. Types of cell injury. One is reversible cell injury. One is reversible injury, another is irreversible cell injury. Irreversible cell injury. Now come to what are the causes of cell injury. Causes of cell injury. It may be hypoxia, physical agent, chemical agents. So hypoxia, physical agent, chemical agents, infectious agents, nutritional imbalance. Then immunological reactions, genetic derangement. In the previous lecture, I have told you these are the stimulus that can stimulate the cell. This is also the cause of cell injury. So hypoxia, physical agents, chemical agents, infectious agents, nutritional imbalance, immunological reactions, genetic derangements, these are the causes of cell injury. Today, now come to reversible cell injury. Before that, I want to know these are the causes of cell injury. What are target site of action on the cell of these injurious agents? Target sites of action in cell. Target sites of action of cell in cell, target sites of actions of the injurious agents in the cell. Number 1, cell membrane. Cell membrane. You know, cell membrane is the protective barrier of the cell, and this is the first protection of the cell. The cell membrane maintains the shape, size, and many things of the cell. If the cell membrane is injured by the injurious agents, the cell undergo injury. The injurious agents in the cell membrane may cause lipid peroxidation. This injurious agent first activates the lipid peroxidase enzyme, and this peroxidase enzyme causes destruction of the cell membrane by lipid peroxidation. Then mitochondria. You know, mitochondria of a cell is nothing but the powerhouse. If the powerhouse is injured by the injurious agent, the cell undergo injury. Then cytoskeleton. You know, microtubules, microfilaments, etc. are the cytoskeletons. There are many roles of the cytoskeletons in the cell. The important role of cytoskeleton is maintain the shape and size of the cell foremost. If the cytoskeleton is injured by the injurious agents, the cell undergo injury. Ribosome. You know, the ribosome attached in the rough endoplasmic reticulum is associated with the protein synthesis. If ribosome is injured by the injurious agents, the protein synthesis will be diminished, and this is nothing but the cell injury. Genetic apparatus. You know, gene of a cell controls or governs all the functions of the cell, all the activities of the cell. If the functioning authority is injured, the cell undergo injury. So these are the sites of action of injurious agent in the cell. Now come to reversible cell injury in details. First, we have to know what is reversible cell injury. If a cell is first injured, after injury, if the cell again come back to normal state, both anatomically and physiologically and functionally, then it is called reversible cell injury. So, injury from which the cell can come back to normal state, both structurally and functionally, is called reversible cell injury. It is called reversible cell injury. Now come to types of reversible cell injury. One is cellular swelling, another is fatty change. One is cellular swelling and another is fatty change. Now come to cellular swelling. Now come to cellular swelling. Cellular swelling. If a cell is exposed to hypoxia, many things may happen within the cell. One is the cellular swelling. Now come to hypoxic cell injury. Now come to hypoxic cell injury. What it means, this is a cell this is nucleus, and oxygen within the cell. If the oxygen is diminished within the cell, this is called hypoxia within the cell. And if a cell is thrown or if a cell is exposed to hypoxia, what happens? What happens in hypoxia? What happens in cell in hypoxia? One is decreased aerobic glycolysis. Decreased aerobic glycolysis. Another is increased anaerobic glycolysis. You know, glycolysis means breakdown of glucose. What happens here? We get energy in the form of ATP. Now come to decreased aerobic glycolysis. So, diminished oxygen in cell. What happens here? Diminished aerobic glycolysis. Aerobic glycolysis in cell. If decreased aerobic glycolysis, what will happen there? There is decreased ATP synthesis. There is decreased ATP synthesis. So, if decreased ATP synthesis within a cell, what will happen in the cell? If decreased ATP in cell, if decreased ATP in cell, what will happen? One is cellular swelling, and another is decreased protein synthesis. Decreased protein synthesis. So, if decreased ATP in cell, what happens? Cell undergoes swelling, cellular swelling, and within the cell there is decreased protein synthesis. Now come to how the cell swells when decreased ATP in hypoxic condition. How a cell swells due to decreased ATP in hypoxic condition. That is the mechanism of cellular swelling. How cellular swelling occurs in hypoxia. We know hypoxia means ultimately decreased ATP synthesis, and ATP synthesis means cellular swelling. So, decreased ATP, you know, if this is cell, nucleus, the shape size of a cell is maintained by many things. One is maintained by cell membrane, another by ATP, by cytoskeleton, etc., etc. So, there is a pump, this is called sodium potassium pump. This pump, for its activity, requires fuel. The fuel of this pump is nothing but ATP. So, ATP is the fuel of sodium potassium pump. ATP is the fuel of sodium potassium pump. This pump maintains the shape, size and cytoplasmic fluid content of the cell. If ATP is diminished, what will happen? The pump will be impaired. So, decreased ATP, what will happen? There is impairment of sodium potassium pump. So if impairment of sodium potassium pump, what will happen? There will be accumulation of sodium within the cytoplasm of cell with escape of potassium. So if sodium potassium pump is impaired, what will happen? Sodium will accumulate and potassium will come out. So due to impairment of sodium potassium pump, what will happen? Accumulation of sodium in cell cytoplasm with escape of potassium. So now we are getting many sodium within the cytoplasm of cell, and you know sodium is osmotically active particle. It cannot live alone. It draws water to it. So accumulated sodium, what will happen there? Accumulated sodium draws water as it is osmotically active particle. Osmotically active substance. As it draws water here, what will happen? Cellular swelling. So due to accumulation of water, cell undergo swelling. Now come to, if hypoxia continues, more and more water will accumulate in the cell. If hypoxia continues, what will happen? In that case, if this many cell has got microtubules, microfilaments like this is the cell. The microvilli, these are the cytoplasmic projections, cytoplasmic membranous projections. These are the microvilli. If more water is accumulated due to continuation of hypoxia, what will happen? There will be disappearance of microvilli, and ultimately there will be disappearance of this, and ultimately there is disappearance like this cell. What will happen? It continues. The microvilli undergo disappearance. So if hypoxia continues, excess water will accumulate in the cell, and ultimately, gradually, the microvilli undergo disappearance, and the cell become increasing size due to excess accumulation of water. This is the cell, water is accumulated, and these are the cytoskeletons, like this cytoskeletons, and these are the cytoskeletons, and these are the cytoskeletons. The cytoskeletons remain attached at the cytoplasmic membrane, cytoskeletons. If excess water is accumulated with the cell, what will happen? This is the attachment of the cytoskeleton cell membrane, attachment of cytoskeleton in the cell membrane. So at the attachment of cell membrane, there is more strength than in this part, So if water is accumulated in here, there will be bulging of this membrane here, and looks like the blebs, like blister. So excess accumulation of water leads to disappearance of microvilli and ultimately formation of blister or blebs. Again, excess water accumulation leads to blebs formation. formation. I have told you decreased ATP synthesis, it is associated with cellular swelling and it is associated with decreased protein synthesis. Now come to how decreased ATP is associated with decreased protein synthesis within the cell. Protein synthesis in cell will be diminished. How? How? You know, within a cell there is endoplasmic reticulum, and this endoplasmic reticulum contains on its surface ribosome like this. These are the ribosomes. We know the ribosomes remain attached with the rough endoplasmic reticulum, not with gum. Rather, it is remain attached with the rough endoplasmic reticulum with the help of energy, and that energy comes from ATP. So ATP is associated with the attachment of the ribosome with the rough endoplasmic reticulum. What happens if decreased ATP? If decreased ATP, what will happen? There will be decreased ATP in the ribosome. So the detachment of ribosome. Detachment of ribosome. Detachment of ribosome from rough endoplasmic reticulum. And you know, rough endoplasmic reticulum with the help of ribosome is associated with protein synthesis, you know it. So protein is synthesized in the rough endoplasmic reticulum, you know it. If there is detachment of ribosome from the rough endoplasmic reticulum, what will happen? There will be diminished protein synthesis. So there is diminished protein synthesis. Diminished protein synthesis. So what we are getting in the cell now, if this is the cell nucleus, we are getting water here and diminished protein. Is not it? Yes, there is diminished protein. You know the protein that is synthesized within the cell. What is the activity of that protein? Some protein after being synthesized, some protein combines with the lipid and it forms lipoprotein. It forms lipoprotein. So if in the cell there is decreased protein synthesis, there will be diminished lipoprotein synthesis. So decreased protein synthesis, what will happen there? There will be diminished or decreased lipoprotein synthesis. If decreased lipoprotein synthesis, what will happen? Some lipid will not get protein to synthesize lipoprotein. The lipid that will not get any protein to make lipoprotein, that lipid will be accumulated in the cell cytoplasm. So this is the red one is the lipid. Now the cell shows mixture of lipid and water within cytoplasm. Is not it? Yes. So if this is the nucleus, around the nucleus there is accumulated water and lipid. This is called myelin disfiguration. This is called myelin disfiguration. This is called myelin disfiguration. What it means? Myelin, it looks like myelin-like. What is myelin? You know, nerve fiber. This is nerve fiber. Around the nerve fiber there is myelin sheet, nodes of Ranvier like this. You know it. If you make cross section here the nerve fiber, what you will get? You will get the red one is the myelin, the nerve fiber. Around this there is myelin. Around this is myelin. Myelin is mainly composed of lipid. So this figure looks like this. So this is called myelin disfiguration. So this is all about the cell swelling in hypoxia. One thing is important, and we have to know I have told you here, in hypoxia there is decreased aerobic glycolysis, and this is the decreased aerobic glycolysis leading such and such. And I have told you there is increased anaerobic glycolysis. If increased anaerobic glycolysis and if the hypoxia is continued, there is formation of lactic acid within the cell, and due to lactic acid synthesis, the cytoplasmic acidity will be increased due to lactic acid, and pH will be decreased, and due to decreased pH there is activation of lysosomal enzymes and cell undergo irreversible injury. So from if hypoxia is continued, the reversible cell injury may follow the irreversible cell injury. Today up to this, thanks all, again we will see you, thank you again.